Today, I'm going to show you something slightly ridiculous. We're going to take a real NHS clinical scoring model written in Excel and in less than a minute turn it into a full web application. No rewriting code, no backend development, no API design, just Excel, Codcel, done. And at the end, we'll do something even stranger. We'll make the calculation run entirely inside your browser using WebAssembly, which means no server calls, no cloud compute costs, and extremely fast execution. So if you like the idea of turning spreadsheets into software, this will be fun. In a previous video, we built a full electric vehicle insurance quotation system, all from an Excel file. That spreadsheet contained the entire pricing model for an EV insurance product. To convert it, all we did was add a few tags to indicate which cells are inputs and which cells are outputs. Then we dragged the Excel file into Codcel, selected Codcel Dioxys Full Stack UI, clicked Generate, waited less than a minute, and Codcel generated the entire web application, front-end, back-end, API routes, everything. Here it is running. We enter some vehicle details, click Run, and instantly we receive the full premium breakdown, vehicle data, location, tax, each coverage price, and the total premium. This spreadsheet even contained large data tables, a vehicle table with over 800 electric vehicles, and a postcode table containing over 190,000 locations. So when we click Run, the browser sends a request to the backend server. Let's prove that. We open the Network Inspector, click Run again, and there it is. The browser called the quotation API, and it returned in about 2 milliseconds. That's pretty fast. But still, it's a server call, and servers cost money, which unfortunately cloud providers seem very enthusiastic about. Now here's where Codcel gets clever. If a spreadsheet does not use tables, meaning the logic is just formulas like if, and, or, and sum, Codcel can do something interesting. Instead of generating a back-end calculation, it generates WebAssembly, which means the calculation runs directly inside the browser. No server, no API request, no network latency, just pure execution on the user's machine. That means faster results, lower infrastructure costs, less server energy usage, and the model never leaves the user's device. So today we're going to demonstrate exactly that. The model we're going to use today is called the NEWS2 score. NEWS2 stands for National Early Warning Score 2. It's used across the NHS. In the United Kingdom, doctors and nurses use this score to detect patients whose condition might be deteriorating. The system monitors physiological measurements such as respiration rate, oxygen saturation, heart rate, blood pressure, temperature, and level of consciousness. Each measurement receives a score depending on how abnormal it is. Those scores are then added together to produce the final NEWS2 score. Based on that number, clinicians are advised whether the patient needs routine monitoring, urgent review, or immediate medical attention. So this small scoring system can actually help doctors identify when a patient might be in danger. And today, it's written entirely in Excel, which is both impressive and slightly terrifying. Let's open the spreadsheet. First, we have the inputs sheet. These represent the patient observations: respiratory rate, oxygen saturation, heart rate, temperature, blood pressure. In Codcel, we simply tag these cells as inputs. Nothing complicated, just tell Codcel. These values come from the user. Now let's look at the NEWS2 calculations sheet. Here we see the individual scoring formulas. Take heart rate, for example. It's one large ifs formula. If the heart rate is below a threshold, score 3. If it's within another range, score 2. And so on. If you know Excel, this will look very familiar. And importantly, there are no tables involved, just logical formulas. Next, we calculate the total NEWS2 score. That's simply the sum of the individual parameter scores. Then we check whether any score equals 3. Because a score of 3 indicates a severe abnormality. That formula uses if and or, and returns yes or no. Next, we calculate the risk band, which classifies the patient into low, medium, or high risk. another if formula, then finally we generate the suggested clinical response, which might say ward-based response, urgent response, or key threshold alert. Again, just Excel formulas, no tables, which makes this spreadsheet perfect for WebAssembly execution. Now let's close Excel and open Codcel. All we need to do is drag and drop the spreadsheet. And just to clarify something, Codcel is not secretly uploading your spreadsheet somewhere mysterious. Your spreadsheet stays on your computer, not in our cloud, not on someone else's server, not being analyzed by an AI that suddenly decides it likes your actuarial models. Your spreadsheets remain your spreadsheets. Now we click Generate Project. Select Codcel, Dioxys Full Stack UI. Scroll down, click Generate. We wait a few seconds. Done. From one Excel file to a full web application. All source code generated locally, nothing hidden. No black boxes, which means your IT department can inspect it, audit it, deploy it, or argue about it during meetings. All perfectly normal developer activities. Let's open the generated project. We'll go to the source code tab. You can see the Rust files here, roots, components, calculation, logic. Now, you may or may not understand Rust. That's completely fine. The important part is that you have the entire source code. This is not one of those tools where the logic disappears into a mysterious executable. Everything is transparent. If your developers want to modify it, they can. If they want to deploy it internally, they can. If they want to stare at it thoughtfully and say, interesting architecture, they can do that too. Now let's build the project. We go to the Build tab, click Run on Terminal. And now the Rust compiler begins doing its thing. This may take a little time. Rust is extremely fast once compiled, but it does occasionally enjoy a moment of reflection before getting there. All right, done. Now we copy the address, paste it into our browser, and here is the application. We select our calculation, NEWS2 score, click Go. Here we see all the same inputs from the spreadsheet. Respiration rate, heart rate, temperature, blood pressure. Let's click Example. To load the same example used in Excel, now we click Run, and instantly we receive the NEWS2 score, the individual parameter scores, the risk band, and the suggested clinical response. Exactly the same logic as the spreadsheet. Now here's the interesting part. Let's open the network inspector again. Clear it. Now click Run. Nothing. No network request. Let's change the heart rate to 120. Click Run again. Still nothing. So what happened? Codcel analyzed the spreadsheet, noticed that the logic does not require tables, and automatically compiled the calculation into WebAssembly, which means the entire model runs directly inside the browser. No server, no API call, just execution on the client machine, which is extremely powerful because now your Excel models can run instantly, without server infrastructure, without network latency, and entirely on the user's device. It's like moving the brain of the application from the cloud into the browser. Now let's do something. Developers enjoy large automated tests. Codcel can generate mass test datasets. We open the Tests tab, click Create Tests. We will generate combinations of heart rate and respiratory rate. Heart rate from 50 to 220. Step 1. Respiratory rate from 6 to 30. Step 1. Scroll down and click Create CSV Tests. And Codcel generates a CSV file containing 4,275 test combinations. Every possible combination in that range. Now we drag that CSV into Run Tests. Let's open the Network Inspector again and clear it. Now click Run Tests on 4,275 rows and watch. Thousands of calculations execute. But the network panel remains empty. No server calls. All calculations are executing locally inside your browser, which is quite satisfying. Let's inspect the first test. Input: 50 beats per minute and 6 breaths per minute, exactly what we defined. Now let's look at the duration. Notice the unit next to the time. That's not milliseconds. That's microseconds, possibly even nanoseconds, which is extremely fast. Blink, and you'll miss it. Actually, blink, and it probably finished 3 calculations. So in this demo, we have taken a real NHS clinical scoring spreadsheet, converted it into a full web application, generated complete source code, run it locally, executed thousands of automated tests, and finally run the entire calculation directly inside the browser using WebAssembly, all starting from Excel. Which raises an interesting question. If so many important models already exist in spreadsheets, why rewrite them from scratch? Just let Codcel turn them into software. If you'd like to learn more about Codcel, visit us anytime at codcel.io.